Now only gravitation.
Yes. How many you have? Only gravity. Okay, so okay, what I will do is that, yeah, Rishita, would you be able to attend the Friday class? Because I want to, yeah, I want to have
Yes, sir.
an extra class on Fridays. Yeah, so then, so it's good. Then we can complete those remaining portion of fluids. And yeah, this was these are the things that I did in those extra that I took, right? Yesterday I took those extra classes and just mechanical properties of fluids and this gravitation portion I revised. Okay, I keep, yeah, okay, we will not yeah. So let us start this new chapter, which is mechanical properties of fluids, right? Okay, so most important quantity that we're talking about is pressure, right? So why we are talking about pressure and all other new quantities in this fluid part, right? Because we cannot talk about the momentum, we cannot talk about the forces, and we cannot talk about yeah, we cannot talk about angular momentum, all these things for a fluid, right? So the parameters which define a fluid are pressure, temperature, number of moles. All these are the things which defines a fluid, right? We cannot associate some momentum or some other things to this fluid, right? So we have solids and fluids. For solids and to be precise, for rigid bodies, we can define all those kinematics. But the kinematics will change for the case of this fluid, right? And why? Because we have a fluid, and what is the crucial property of the fluids? What is the crucial property of the fluids? So they don't have definite shape and size. And as because they don't have any definite shape and size, then we cannot define all the attributes that we were defining for the case of the solid objects, right? So for the case of fluids, we have different fluids. So that is why fluids have different parameters. So Ilham, oh, yes, you are 5 minutes late. Hello, Ilham. Assalamu alaikum.
Assalamualaikum, sir. Sorry,
Walaikum
sir.
assalam.
I was
Hey, no worries.
stuck.
No worries, no
Mm.
worries. So yeah, we have just started, right? So we have just started, and how much you have
Okay.
prepared until now? Oh, please, like yes.
Yes, sir. I revised everything. Only fluids I did, but I just have to revise one more time.
Yeah, yeah. So, okay. So I've just started, right? So fluids have they don't have any definite shape and size, so we can't assign our regular parameters, momentum, velocity, and all these things to these fluids, right? So that is why fluids have different parameters such as pressure and temperature and let's say uh, number of moles, right? And whenever we talk about the velocities, then we talk about the velocity as a whole. So whole system is right. So right. And when I talk about fluids, so they have so they can be liquids and they can be gases also, right? So these are these comes under the fluids, right? Okay, so what is a pressure, right? So let's say if we have some object, right? If we have some object which is placed in this fluid, right? So this will experience some force from every side, and that would be normal force, right? So pressure is defined as the force per unit area acting on an object, right? And this force is normal, right? So mathematically, how do we represent pressure? So average pressure is, and I will not write this average part subsequently, right? So this is defined as normal force divided by area, right? So this is the pressure, and for a small force, right? The pressure is also defined as limit delta A tends to 0 and delta F by delta. This is also for a small, for a very small change in force. So this is the pressure, right? And the SI unit or SI unit of the pressure is this is Newton per meter square, and it is also written as or Pascal. Right? This is Pascal. Okay, and what would be the dimension? So it is a scalar quantity, right? And dimension is what? Dimension. What is the dimension of force? Yes, everyone.
ml
What
t minus 2.
MLT minus 2. So force is MA, right? M is kg. This is meter per second square. This is MLT minus 2. Yes. This is force divided area. Area is meter square, right? L square. So this will cancel and this is ml minus 1 t minus. So dimension is ml. So this would be the dimension. Right, everyone. Is this clear? Let us do that and then what are you saying? One, yeah, talk to them. Maybe tomorrow I will talk to them. Is it still lagging, Akib? Is it still lagging? Yes, is my voice still lagging, guys?
No, sir.
Okay, good. We have this question and where is this question? Got disconnected. Got disconnected. Yeah. So this is the question, right? And Thai bones, you guys have biology in your school, right? So thigh bones are called femurs. Each of sectional area 10 centimeters square. The upper property of texture. This is by area. And there are two femurs. So total area is how much? Yes, guys, I got disconnected. So I'll have to talk to my internet provider. Yeah, so as I was saying, that total area is how much? 10 centimeters square. So is this in SI unit, guys? Is this in SI unit? Who got disconnected? Oh, where is Akib? Yeah. So is this in SI unit, guys? This is centimeter square. So this is not in SI unit. So we have to change this in SI unit, right? So 10 centimeter into centimeter. So how do I change centimeter to meter? That is 1 by 100 meter and 1 by 100 meter, right? So this will cancel. So this is 2 into 10 to the power minus 3 meter square. So this is the area, right, guys? And what is the force? Force is the weight on the thigh bone, right? So their mass is 40. So force would be how much? Force is mg. So this mass is 40 into g is 10. So 400, right? So then we can calculate pressure is F by A. So this is 400 divided by 2 into 10 to the power minus 3. And this is 200. So 200 into 10 to the power plus 3 Pascal. So this is 2 into 10.
So your voice is lagging a little bit for me.
My, yeah, my voice is
Yes, sir.
so. Is it okay now, guys? Yes, guys, is my voice clear? Yes, guys, is this clear?
Yes.
Please note it down, note down this problem. Yeah, please note down parameter. That is very crucial for, please note it down. So this was the question, right? Already this is given. Right? So this was the example. This was given. Please note down this. Whenever you guys have noted it down, please tell. Yeah, whenever you guys have noted it down, please
Done, sir. Sir, done.
done. Is it
Yes,
done,
sir.
everyone?
Yes, sir.
Okay, so now let us talk about the other saying something. Yes, Elam, are you saying something? Hello, can you hear me, Elam? Are you saying something?
No, sir. I was just saying I'm done.
Oh, good. Yes, welcome back, Akib.
Thank you, sir.
You got disconnected, right? So
Yes.
one other important parameter is density, right? So density, and whenever we are talking about density, so this is mass density, right? So this is defined as the total mass per unit volume, right? So let's say this is represented by rho, and this is mass by volume. So this is very important quantity, right? And density has a dimension what? So this is mass, which is kg, right? Volume is meter cube. So this is kg per meter cube. And dimension would be what? This would be ml minus m, right? So this density is very important. This is another parameter which is very important, right? And in your book, some of the densities of some fluids are given. So let's say water has a density of 1000 kg per meter cube, and all the other densities are given. So when we know these pressure and when we know these density, so there is a very important law that governs the pressure at different heights, right? So let's say, yeah, and that is called the Pascal's law. So proof is not needed, right? What does this Pascal's law says? It states that pressure at same height is so proof is not that much important. So we have to just remember that let's say we have some fluid, right? And let's say we are calculating, let's say this is some barricade or something, right? So from here, let's say we have this thing, this division from here, right? And this is the liquid. So if I calculate the pressure at A point, and if I calculate the pressure at B point, so these pressure are equal, right? So pressure at A point would be equal to pressure at B point. This is a very important relation. This Pascal law is very important, and this has various use, right? So in hydraulic machines and all those things, in those hydraulic pressures, these Pascal law is very important, right? So have you guys seen some hydraulic machines?
Yes, sir.
Yeah, so those hydraulic machine, by applying a small amount of force, we can generate a very large amount of force. So that is the use of those hydraulic machines, and they use this Pascal law very intelligently, right? So they use this Pascal's law. So yeah, and where do we use this Pascal's law? So we have this variation of pressure, right? Before we do that, let us understand that what is atmospheric pressure. So atmospheric pressure is defined as ATM, right? and this is equal to 1.013 into 10 to the 5 Pascal. So we represent, right? So this is the atmosphere pressure, that is the variation of at right. We have a fluid, right? And we have immersed some object in this. So this object is immersed, right? So this liquid is experiencing a force from this side, pressure from this side, pressure from this side, right? And pressure from this side, right? And pressure from this side, right, guys? Because all the because the pressure is uniform, right? So all the objects are experienced at sides, right? Is that
Yes,
clear,
sir.
guys? And you see that
Yes, sir.
these points are at same height. So these pressures are same. So these left and right will cancel each other out. Why? Because they are at the same height. So from Pascal's law, we can we can subtract we can cancel out these pressures, right? So only the pressures which would be contributing would be the upper and lower pressure, right? So let's say the lower pressure is P2 and upper pressure is P1, right? And this thing is at equilibrium. And let's say the height of this thing is, let's say the height of this thing is H, right? So can you guys tell me that, yeah, can you guys tell me that if this thing is at equilibrium, what is the meaning of this thing if it is at equilibrium? What is the meaning of this? The meaning of this thing if this at equilibrium? What is the meaning of equilibrium, right? This thing is not moving. All the other forces which are acting on this thing, they will cancel each other out. That is the equilibrium. So that is the meaning of equilibrium, right? working very badly. So sorry about that. Can you guys hear? Yes, can you guys hear me?
Yes, sir.
Everyone, can you guys? Yeah, hey, you have this thing. Let's say one force is acting in this way, and the other force is acting in this way, and this is at equilibrium. Equal to F. Right, everyone? Am I audible? Is my internet? Hello, everyone.
Yes, sir.
Yes, guys. Yeah. So that was, and we can write. So these are pressures. So how can we write force by these pressure? What is the relation between force and pressure? So we know that pressure is force by area. See the V1A and F2 would be V2A, right? So what I will write in here is F1 forces are due to these pressures. What is the other force that is acting on this thing? This has some mass. This has some mass. So what would be the other force, which is always there? This has some mass m. So what would be the other force which would be acting on this thing? Yes, guys, why are you guys are silent? I know we have lost the man. Being expired. Ishita, Arif, Ilham, am I audible, guys?
Yes, sir.
Yes, sir.
Yes, guys, am I audible? Yes, I think the downward pressure and the upward pressure. But these pressure are different because they are at different heights. We know from Pascal's law that pressure at same height is equal, right? So these left and right cancel each other out. Only these one are acting upwards on this object. Is there any other force which is acting on this object? Always, right? Correct, everyone. So there are three forces. Due to these pressure, there are two forces, and due to gravity, there is this third force, right? So at equilibrium, what will happen? At equilibrium, what will happen? at equilibrium, downward forces are how many? F1 and mg. This is equal to F2. This is the equilibrium condition. All the downward forces are equal to the upward forces. Is this thing clear, everyone? Is
Yes,
this
sir.
thing clear? So this is F1 is P1A, mg. This is P2A. So if I write, if I take this thing in the other side, so this is P2A minus P1A and this is mg. So I can take this P2 minus P1 and A is common and this is mg. So P2 minus P1 is mg and A, right? Now I know what is the density. I know the density, I know the mass, and I know the volume. So how this mass density are related with volume? So rho is mass by volume. So I can write mass as rho into volume, right? So if I put this thing in here, so this is rho Vg divided by A. And I know how what is the volume of this cylinder. So volume of this cylinder is base area into height, area into height. That is the volume, right? So volume is
Sir,
area
I
into.
had a internet problem, so I left the meeting unexpectedly.
Oh yeah. So okay, I will explain this thing again. So as I was telling, that at equilibrium, these forces will cancel each other out. So this thing had three forces. One was this downward force due to this pressure. The other was this upward force due to this pressure, P2, and then the downward force due to this gravity. So we know that this thing is at equilibrium. This is not moving, which means that the downward forces are balancing the upward forces, right? So downward forces were F1 and mg, and this was balanced by this upward force F2, right? So then I wrote the value of F1, F2, and then we got this thing. And I know that mass is related with density, right? Density is mass by volume. So I can write mass as rho into volume, density into volume. I plug that value. And I also know that volume is how much. So volume of this cylinder is base area into height. Pi r square into h. Pi r square is area, right? So volume is area into height. If I put that value, so what will I get? This is rho. Volume is area into height. And this is A. A will cancel. And I will get P2 minus P1. This is rho Hg. If I write it properly, so this is H rho G. So this is how the pressure varies with certain height. So this height we know, right? So this was the height in which we have placed this thing. So this was the height, right? This was the height. Okay. So so this was this was the height of this object, and this will be the variation of the pressure due to this height, right? And if I put this thing in the air, right? So let's say if I put this thing is exposed to air, right? So let's say I put this thing in here at the surface, right? So now P1 will become how much? Now this is in the air. So this will become how much? Yes. This part is in the air. When I keep this thing in the air, so this would be atmospheric pressure, right? This is PA, not the Pascal. This is P and subscript A. So when I put when we put the upper part at the surface, right? Then P1 would become atmospheric pressure, right? So this result would be P2 minus PA and H rho G. So this is how the pressure varies with the depth, right? So if I calculate P2, this would be equal to PA plus H rho G, right? So this would be the value. Do you guys have anything that you want to ask? Any doubts in this calculation? Any doubts, guys? Any doubts?
No, sir.
Okay, then please note down all these things, right? So please note down these, and we will do couple of questions. And yeah, number of moles and density, etc. Yeah, whenever you guys want me to scroll down, please tell. Yeah, whenever you guys want me to scroll down, please tell.
Done, sir.
Yeah, then please, this is at same height or same level. Calculate, let's say, if we have this liquid, and if we calculate the pressure at this point and pressure at this point, right? So PA would be equal to PC again. And let's say if I calculate pressure at this point, C, so PA would not be equal to PC because they are at different heights. Whenever they are at same levels, then these are Whenever you guys have noted it down and you want me to scroll down this quickly, so just try keep it word. Okay, what I will quickly quickly barometer. Yeah,
Done, sir.
yeah. There's it now. It's MG is downwards with the thing. You guys have completed the yes, whenever you guys have noted it down.
Can you scroll, sir? Done, sir.
Then, good. So what did we get? We get a change in pressure at different heights, right? So this thing, change in pressure is what? This is a special name, and it is called gauge pressure, right? So the change in pressure due to different heights or levels is called the gauge pressure, right? And its value we already know. So what was the change in pressure? P2 minus PA, P2 minus P1, this was H rho, G, right? So it's it is equal to product of H rho and G, right? So P2 minus P1 is H rho G. This is the gauge pressure. And let me quickly talk about two instruments to measure uh, the pressure, right? So instruments measure pressure, right? So they are mainly they are two instruments. One is barometer, right? This is used to measure the atmospheric pressure, and we have this manometer. This is used to measure the gauge pressure, right? So these are the instruments that we use. So let us talk about this barometer first. So in barometer, it uses mercury fluid, right? And which vapor has a very negligible pressure, right? So how do we calculate the atmospheric pressure? It is used to calculate or measure the atmospheric pressure. Right. So how do we measure the atmospheric pressure? So the device is made up, right, like so we have this mercury fluid, and this is a tube, mercury tube, which is placed, right, like this, and the mercury fluids are right. So if I calculate the pressure at this point, right? Pressure at this point and pressure at this point. Let's say this is A, this is B, and let's say this is, so this is, in here we have mercury in vapor phase, right? So this region has mercury in vapor phase. So let's say this has some pressure P. This has some pressure P. Here P is pressure by mercury vapors, right? So this P would be how much? Zero, because the pressure exerted by the mercury vapor is very low. So this pressure is zero. Now, from Pascal's law, what do we know? What can you guys say about the pressure at A and pressure at B? What can you guys tell? Yes. What can you
Both
so
of them are equal.
absolutely correct, Akib sir. So after a long time you have spoken, and yeah, and you
I'm having
see,
throat pain.
uh,
That's why I'm not
oh,
talking.
sorry. Because yeah, usually you uh, talk along, right? So yeah. Okay, sorry. Then please don't speak. So now Elam or Rishita will speak now. So now you see that this place is in the air, right? So this point B is, because in B is at the surface. B point is at the surface. B is at open surface, right? So PB is atmospheric pressure, right? Is this clear, guys?
Yes, sir.
And
Yes.
from depth or height variation. From depth, let's say this height is h. So from depth variation, right? We know that from that relation, what would be PA? What would be PA? PA would be P plus density of mercury, G and H. Am I correct, everyone?
Yes, sir.
So you guys see that this P is zero, right? So PA is density of mercury and G and H. Now we know that from here, right? From one, we know that we can write PA equal to PB. Now PA is how much? This is rho mgh. PB is atmospheric pressure. So now whatever, because we know this rho m, right? Density of mercury we know, G we know, and H we can calculate. So let's say if we bring this barometer at different places, so this height will change. And by calculating the height, what we can calculate? We can calculate the atmospheric pressure. So that is how this barometer calculate the atmospheric pressure, right? So depending upon the different heights, so whatever height this mercury has risen, then with the help of this height, we can calculate this atmospheric pressure. So that is how this what barometer measures this atmospheric pressure. Similarly, we have this monometer, because we have a very less time, so I will just directly write. Right. I will not explain the thing, and at some other time, because Elham has this exam tomorrow. So tomorrow you have this exam, right? Or 21st.
So I have tomorrow.
So why did you start this much late your preparation? When did you start preparing? 2 days
So I
before.
started last week. Now I just revised.
Oh, you are revising. Good, good. Yeah. So, monometer. So what does this monometer measure? This measures the gauge pressure, right? So how does this measure gauge pressure? So we have this spherical tube, and then this is connected by this U-shaped, right? So U-shaped, my drawing is bad. Okay, so this point is, let's say, this point is A, right? So we have some liquid, and this is, this point is B, right? They are at the same level. So this point is B, and this is open. This is open, and we have some whatever material that we want to calculate the atmospheric pressure, the pressure. So that material is here, right? So this is, yeah, this is some material, right? Some gases that we want to calculate. So this has some pressure P, and in here the pressure is atmospheric pressure, right? So this has some height h, and from Pascal's law, what would be this P and PV point? What would be this P and PV point? From Pascal's law, what do we know that this P is here, right? So from Pascal's law, we know that PA is PV, and we know that PA is how much? This is P, and PB is how much? PB is PA plus rho GH, right? So then we can calculate P minus PA equals to rho GH. So we know the density of this thing, this material, and we know this height. So we can calculate this change in pressure, which is the gauge pressure. So that is how this monometer works. Is this clear, everyone? Do you guys understand this barometer and monometer? Both uses the idea of
Yes.
Pascal. Yeah. So please note it down. Please note down from here. And if you guys have any doubts, please ask. And I wanted to do some question, but I will not get any time. But you guys look at the example. What are those examples? So the diagram is it has a different diagram. Right here. So I will make the diagram this way. Monometer has a different diagram. Okay, but what was the example that I wanted to talk? So you guys please look at the example 9.2, 9.3, 9.4. All these examples are very important. When you do this 9.4 example, page number what? Page number 180, right? Page number 184, you look at those examples 9.1, 9.2, 9.2, 9.2, 9.3, 9. Yeah, whenever you guys want me to scroll down, please tell. Yes, whenever you want, scroll down, please. Noted, everyone.
Yes, sir.
Yes, sir.
Yeah, why did you guys tell me that the um, the note down? It is made up of very negligible vapor pressure. So you guys have noted it down, please tell. Yeah, whenever you guys have noted it down, please tell. Noted, everyone.
Yes, sir.
Okay, so then please note down this thing, and this has a different diagram. So, yeah, this is like we have this thing in here, this tube, and then I have this. Okay, and some air is there, so then I can. These are the 2 points. This is point A, and this is point at the same height. This is open because liquid is air, so this pressure would be just P right at this point, and this pressure would be due to this. This would be correct, right? Please quickly note it down, and then I will because only 4 minutes are left. So I will write down the things that we learn in the subsequent. I will explain these things later, but because Ilham has the exam tomorrow, but so I will write those things. And Ilham, you please practice those example questions, right? Please practice those questions. Noted, everyone? Everyone noted?
Yes, sir.
Yes, sir.
Okay, so then we have this hydraulic machines, and we have these maybe hydraulic lift, or we have hydraulic right. What is the hydraulic lift? And maybe other thing is hydraulic pressure, right? So these are the hydraulic machines that we use. And what are their purpose? So the purpose of them that to use minimum amount of effort to have a large amount of right, and they uses the idea of they uses the idea of Pascal's law, right? So let me show you the schematic diagram of Pascal's law and how do they use this thing. So let's say we have this container, right? And this one is this one piston is the small area, right? That we are applying a force, and then we have this larger area, right? So then we have this larger area, which is this one, and we have this car which is kept in there, right? How do we make a car? Right, so we have this car, and this car is kept on this thing. So we are applying a small amount of, let's say this area is small, right? You guys can see that this area is small, and we are applying an F1 small amount of thing. This has some area. This is some water or some fluid. So at this point, they have some area A1, right? This area is large. This is A2, and they will experience some force F, right? So we know that these 2 points are at the same level. Let's say this is A point and this is B point. So from Pascal's law, pressure at A point would be equal to pressure at B point, right? And what is the pressure at A point? So this is F1 by A1, right? Pressure at B point is F2 by A2, right? And we know that, so what would be F1 by F2? This would be A1 by A2. So if I write them F2 by F1, this would be A2 by A1. And I know that area of second thing is larger than area of this thing, right? So A2 is greater than A1. Is this thing clear, guys? Is this thing clear?
Clear, sir.
So A2 is greater than A1, so this would be how much? So if I take this thing in the left hand side, so A2 would be greater than 1, right? So which means that F2 by F1 is greater than 1. So F2 would be greater than F1. So what did I get? If I increase the area, right? If I increase the area, then I'll get the maximum amount of force. So I am applying a small amount of force in there, right? I have applied a small amount of force in this side, but due to increase in the area, I am getting a force in this side, which is very larger. right? So in this way, we can get by applying a small amount of force, we can get let's say 10 times or 100 times larger force than this one. Let's say at this point I'm applying a 10 Newton force, but in this side by using the Pascal's law, I will get 100 Newton force, right? So I'm using a small amount of effort in this thing, and then I can lift a car, right? So can you guys lift the car on your own? Can you guys do that?
No, sir.
No. But using this hydraulic machines, we can exert some small amount of force in this thing, and then we can get a huge amount of force in this side by using this just simple Pascal's law, right? So that is the use of this Pascal's. And there are important things which I'm just writing. I will explain this thing in on Friday. So on Friday, I will take an extra class, and Rishita and Akib has so they have agreed. So can you take? Are you? So can you take an extra class or can you attend an extra class on Friday now? Yes. Can you attend an extra class on Friday? Alarm, is that okay for
Yes.
you?
Sorry,
Rishita,
sir.
yeah. So can you attend an extra class on Friday?
Friday.
Yeah, Friday. Let's say at 8 p.m., which would be 5. Yeah, 5:30 p.m.
Sir, for which chapter?
This chapter, the second part, because only few things are left. So only yeah, Bernoulli's principle. I will write this time in here. And only viscosity, surface tension, and surface energy. These things are limited. And the last topic is that capillaries. Right? So those things I will do on Friday. So will you be available at that time on Friday?
Yes, sir, most probably.
Probably is 50-50, right? Okay.
Yes, sir, because I have an exam on Sunday, so
Yeah, yeah,
but
okay. For
yeah,
1 hour, yes.
but it's English, so it's fine.
Yeah, yeah, English is literature language. You can prepare. You don't need that much amount of time. Okay. So I will just quickly write the important things, and I will explain these things in the subsequent Friday class. So equation of continuity, right? This says that velocity, area into velocity, this is equal to A2 into B. This is a very important relation, and this is used in streamline or steady flow, right? And then you have these Bernoulli's equation. Bernoulli's equation says that if you have, let's say, this thing, right? So this fluid has some velocity at this point, some height h1, some height h2, some velocity at this point, some pressure at this point, some pressure at this point. So Bernoulli's equation says that P plus half rho v square plus rho gh, this would be constant. So this is the Bernoulli equation. So it says that P1 plus half rho V1 square plus rho G H1, this would be equal to P2 plus half rho V2 square plus rho G H2. So this is the Bernoulli's equation. Okay, what are these? These topics are not that important, right? Yeah, these topics are, this Bernoulli's equation is very important. And I will do these explicitly. So I will elaborate these things in Friday class, but Ilham has exam tomorrow, so I'm just writing these things. And then we have these Torricelli's law also. So you right. So I will you just look at what is the equation. So what is the equation? I will just write them. And yeah, this is also important. So Ilham, you just remember these right. Torricelli's law is what this is PA plus half rho 1B square and plus rho Gy1, this is equal to P plus rho Gy2. So this uses this Bernoulli's principle. Right, if you look at the diagram, then you would be able to understand very quickly. So this is a tank, right? And you have this hole in the tank, right? This height is so let's say this is pressure. This height is y1, and this height is y2, and this difference is h. So this is experience atmospheric pressure, right? And this is experiencing pressure. So by applying the Torricelli's law, we get right because this doesn't have any velocity, right? So you will get we have this. Okay, I'm rushing too much, but yeah, you guys just not you, all of you guys. Elham, you just remember. Okay, these are this is y2, this is y1, and this is v1 with which this liquid is flowing, right? So you have this sorry series law. So you just quickly note it down, everyone, and then we'll end the class. Okay, I will explain these things on Friday. But Elham, you just memorize these things and just solve some questions based on this.
Yes,
Okay.
sir.
So these topics, only these topics are important. So just this is very important. And Bernoulli's equation, Torricelli's law, that with what speed the water will come out of that hole. So that is given by this Torricelli's law. And then you have these, yeah, barometer, manometer, and all. That is why I keep saying that you guys revise all these things, right? Because at the last time when you guys will try to remember all these things at one point, then you guys will forget, right? Always repeat these things. Okay. Yeah, whenever you guys have written, please let me know and I will scroll down this screen. Whenever you guys want me to scroll down, please. Yes, sir. Noted everyone.
Yes, sir.
Okay, so please note down. These are the results that I have written directly. You guys solve these. These are important, right? And when you look at Torricelli's law and we compare with this Bernoulli's equation, then you will see that. So at this point, we have this atmospheric pressure, and we have this V1 speed, and we have this height Y1. So Bernoulli's equation would be how much? VA plus half rho V square plus rho G Y1, right? And at this point, this is pressure P, right? And height is Y2. And there is no speed of the liquid in this part, right? Velocity V2 is 0. So then you will get this relation. And from this relation, you can calculate V1. So you will get the speed of this U flux that you calculate. So you will get speed of U flux, right? So that is called the Tory series. So the speed of U flux is given by this Tory series. Whatever you guys have written, please tell.
Done, sir.
Okay, so all the best, Ilham, for tomorrow's exam. And the important thing is that you do some question based on this. So you have those NCRT examples. Please solve them. Then you'll get an idea of these things, right? And yeah, so see you guys on Friday, right? All the best, Ilham. And Akib, you have also these exams which are going on. So all the best to you too. And Nishita's exam will happen after September.
Thank you, sir.
All the best, guys, and bye bye, everyone. See you guys. See you guys